A Telebyte video.
Welcome to a demonstration of IEEE 802.3 CG 10BASE-T1L compliance testing using 1.0 volts peak-to-peak and test mode 3. This demonstration will feature analog devices evaluation board and Ethernet PHY evaluation software with Telebyte's digital analyzer, probe, and software. This demonstration will show you how to identify problems, analyze transmitter power spectral density and power level, perform repeatable testing, see clear pass-fail results, and produce printed reports and graphs. The equipment and software in this demonstration includes analog devices eval ADIN 1110EBZ EVM evaluation board, analog devices Ethernet PHY evaluation software, Telebyte's 4975 digital analyzer and software, as well as Telebyte's 4975 P01 probe for signal capture. This setup can test with 1.0 volts peak-to-peak and 2.4 volts peak-to-peak. It can also test with test modes 1, 2, or 3. Let's take a look at the devices and software we'll be working with today. In the bottom left-hand corner, we have our analog devices evaluation board. This board receives its control and power via a USB connection that goes to the Telebyte 4975 digital analyzer, which is loaded with Telebyte's 500 software, as well as analog devices Ethernet PHY evaluation software. The evaluation board is also connected to the Telebyte 4975 P01 probe via an adapter cable from a 3-terminal SPE screw connector to an RJ45 connector. The probe also has a 100 ohm termination on the front, and from the back it is connected to the digital capture card that is installed in the digital analyzer. In order to enable USB power on the ADI evaluation board, do the following. At P5, connect a USB cable. At P4, jumper pins 3 and 4. Next, we need to connect the probe to the 4975 digitizer card. This is done by using an SMA to SMB cable, which is connected to the digitizer card and also to the back of the 4975 P01 probe. Then we need to set the attenuation to 0 dB. This is accomplished by manually sliding the red switch on the probe to 0 dB. Let's take a look at the software in action.
Hello, today we'll be testing the analog devices ADIN 1110 evaluation board, single pair Ethernet 10BASE-T1L. You can see we have a termite serial. We're using termite software and a serial connection to the analog devices eval ADIN 1110 EBZ board. And I also have the Telebyte 500 series signal analysis software open. So you can see I'm currently talking to the device at COM13, 115,200 bits per second, 8 bits with no parity, no handshaking. So I have a note sheet here to put the device into test mode 3 for our PSD, power spectral density, mass testing, and also to see what the power transmit level is. So I use some PHY write and read commands here to the device to put it in the mode that we would like. So we enter a software power down mode by writing that register. Read back a 17 so that we know we're powered down correctly. Then we want to pull out a negotiation. And we're enabling a forced mode. Then we're writing a 6000 value to register address 0108F8. That puts us in test 3. And then we can the far right here. So now we've got the device in test mode 3 and using our note sheet here. Then we can go to the Telebyte 500 series software and we can open up the spectrum analyzer mode. And this is the frequency domain view out to about 25 megahertz here. So we have a mask library, and this looks like a test mode 3 signal with idle transmissions. We'll use our 10BASE-T1L mask, and we're in a 1-volt mode, and I'll put the lower mask in green here. You can see it's not defined over the full 20 megahertz range, but it's defined here up to 5 megahertz. And then we'll put our upper mask in red. See, the upper mask is defined out to 20 megahertz. So this scale is times 10 to the 7th. So this is 20 megahertz, 15 megahertz, 10 megahertz, 5 megahertz. You can see the line is falling in between the upper and the lower mask. So the signal of the analog devices ADIN 1110 phi is in blue. And so the signal looks like it's passing just fine. And what we'll do then is we'll close the spectrum analyzer view and we'll come to our capture software where we'll take a capture file. We'll sample at 500 million samples a second for 2 seconds. And we'll use channel 1 with AC coupling and a 100 ohm load impedance with a 2.5 volt range and a 0 dB attenuation. And we'll start the capture. So this captures the signal for 2 seconds. We can look at a spectrogram view here of the signal. So you can see it's a 20 megahertz signal. So it's a color mapping. The yellow is higher power and blue is lower power. So you can see you've got about a 20 megahertz band. Our probe and our analyzer can capture up to 250 megahertz bandwidth. So this could be used for 10BASE-T1L or 100BASE-T1. I can run the analysis here on the software. So it's going to analyze the signal between my 2 red cursors here. And so the first thing we have is our time domain view of the signal on the left. Then we have our frequency domain signal in the middle. And then we have our amplitude probability density function. So this is a ternary signal. It's a 3-level pulse amplitude modulation signal. So I see kind of +1s, 0, and a -1 value. And then we can zoom in here by drawing a rectangular window around our time domain signal and just to check on it to see if it looks like what we're expecting. So this definitely looks like a PAM3 signal with +1s, -1s, and 0 values here. So these analog signals get coded into code groups, and they'll, for EMC compatibility and to eliminate any DC bias, the signals get coded by the physical coding sublayer into 4 bits from different triplet symbols here at the PAM3 level. So what we do now is we'll run a test report, and we have the IEEE 802.3CG test reports and also the Ethernet Advanced Physical Layer. We're using the analog devices evaluation board today. It's the eval-ADIN 1110 EBZ board. And for test mode 3, we just took the capture here. And on the previous videos, we did test mode 2 and we did test mode 1. So I can load those signal captures here. But we basically took a 2-second capture in the different test modes with the analog devices board, and then we can automatically generate a pass-fail report based on the single pair Ethernet 10BASE-T1L IEEE 802.3CG standard. This generates a PDF report with the date and timestamp here. See the table of contents. And then you see the test information, our software versions, our serial numbers of our digitizer, the manufacturer and the model and time. So here you see the 1-volt transmitter output voltage. That was from test mode 1, was a pass. The output droop level was from test mode 2 for a 1-volt peak to peak. And the jitter was from test mode 1. Here we get to test mode 3, our transmitter power spectral density. So in a 1 volt peak-to-peak mode, you can see we have our upper limit line out to 20 megahertz and our lower limit line out to 5 megahertz. And our blue is the transmitted signal. And so the transmitted signal must stay between the upper and the lower mask where they're defined. And then you can see that it was a pass for the lower PSD mask and a pass for the upper PSD mask. Then what we do is we integrate the area under the signal to calculate the maximum power measured. So for a 1 volt peak-to-peak mode, our minimum power should be a negative 0.2 dBm. The maximum power transmitted should be 2.2 dBm, and we measured 1.7 dBm. So that's a passing result. Then our other results here were from test mode 1 with jitter and short-term variation. So you can see test mode 3, we're passing. We actually, Analog Devices did a very good job because they're passing all the tests in the 802.3 CG standard using the Telebyte 500 series signal analysis software and the Telebyte probe.
Thank you for watching this demonstration today. Here are other videos that you'll find in this series.
We would be happy to provide you with more information. Please go to telebyte-SPE.com to learn more, or you can send an email using sales@telebyte-SPE.com.